Hello, welcome to our class today. We shall be looking at um, IGCSE mathematics, and we want to basically learn the intersection of straight lines and curves. But basically, let's look at the concept of the intersection of straight line and curves. We can first look at the concept of roots of quadratic equations. So let's start from the concept of roots of quadratic equations. Fundamentally, we know that quadratic equations are equations of the form ax squared plus bx plus c equals to 0, where a being the coefficient of x squared, b is the coefficient of x, c is constant. Now, what do we mean by roots of quadratic equation? Whenever we solve quadratic equation, we expect to get two answers, and the two answers are basically called the roots of the equation. Some can call it x1, x2, or we just say x to be the answers or the roots of the quadratic equation. We expect to get two answers. Now, what do we now mean by nature of the root of the quadratic equation? That is the nature of the answers we are obtaining. How do they look? We will explain it in this video. Let's take some examples. If we have a quadratic equation like if our quadratic equation basically look like, let's say we have to solve x squared plus 2x minus 8 equals to 0. We want to solve that. X squared plus 2x minus 8 equals to 0. Okay, so I'll be using quadratic formula to solve the quadratic equation shown. The quadratic formula states that x equals to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Okay, so let's identify a, b, and c. A is coefficient of x squared. Basically, we have 1 as coefficient of x squared. B is coefficient of x. So what we have behind x is plus 2. So that's what's meant by the coefficient. Plus 2 is same thing as 2. Then c is the constant term. That is the term without x at all. And that's equals to negative 8. Term without x. Okay. Now let's provide solution to that quadratic. The formula x equals to minus b. So let's apply that formula. X equals to negative, b is 2, plus or minus square root of b squared, that's 2 squared minus 4, a is 1, c is minus 8, negative 8, divided by 2a. Then a is 1. So x equals to negative 2 plus or minus square root of 2 squared is 4 minus negative 32 divided by 2a. 2 times 1, that's 2. X equals to negative 2 plus or minus square root of Negative times negative is positive. 4 plus 32 is 36. All divided by 2. We have x equals to negative 2 plus or minus square root of 36 is obviously 6. 6 times 6 is 36 divided by 2. X equals to negative 2. We operate at the middle here. We can take the positive sign first. We have plus 6 divided by 2. That's 4 divided by 2. That's equals to 2. First answer for x is 2. We'll still operate at the middle here. We can take the negative sign this time around. Let's take the negative sign this time around. We have x equals to negative 2, negative 6 divided by 2. That's negative 8 divided by 2. And that's negative 4. So x equals to 2 or minus 4. So obviously we said the quadratic equation is expected to have two answers, and those two answers are called the roots of the quadratic equation, 2 minus 4. Now, we are looking at what kind of root is this, what kind of answer is this. We can see that the two answers are unique, they are different answers, and they're actually real numbers. So we say the quadratic equation that we first solved provided us with real and distinct roots. We have real numbers completely different from each other. 2 is completely different from negative 4. So real and distinct roots. Okay. Let's look at another quadratic equation and let's see what kind of answer we'll generate. Let's go to question 2. If I are required to solve x squared minus 6x plus 9 equals to 0 using the quadratic formula, you can pause the video, try to see if you'll be able to solve using the quadratic formula. First is to quote the formula x equals to, pause the video, try to quote the formula minus b plus or minus square root of b squared minus 4ac all divided by 2a. Okay, it's quite easy and straightforward. Let's identify a, b, and c. A is what you have behind x squared, that's coefficient of x squared. A is 1. B is what you have behind x, negative 6. Please, the negative sign, very important. C is the constant term, the term without x. So the term without x here is 9. Okay, great. So let's substitute the values of a, b, and c into the quadratic formula. Okay, so we're going to have something like x equals to, first you notice there is a negative in the formula, so I'm going to write the minus in the formula, the negative in the formula. Good. Then b itself is negative 6 plus or minus square root b squared, that's negative 6 squared, minus 4 times a, 1, times c, 9. Okay, all divided by 2a. That's 2 times 1, obviously. X equals to, now the negative in the formula multiplies the b, which is negative 6, that becomes plus 6. So plus 6 is saved as 6, plus or minus. The plus or minus, or the plus and negative in the formula, helps you to generate the two answers required towards the last stage. Okay, square root of b squared, negative 6 squared, minus 6 times minus 6, obviously that's plus 36. So because negative times negative is positive, so negative 6 squared is plus positive 36 minus, okay, 9 times 4 here is also 36. Okay, all divided by 2 times 1 is 2. So we have something like x equals 6 plus or minus square root of 0 all divided by 2. We have x equals to 6 plus or minus square root of 0 is 0, 0 times 0 is 0, divided by 2. So we have x equals to 6 plus 0 divided by 2, as we did previously. And on the other hand, second answer for x. So to get two answers, operate at the middle here with the plus or minus. Use plus, then next you use minus, negative sign. X equals to 6 minus 0 divided by 2. Okay. So 6 plus 0, that's 6 divided by 2, s is 3. 6 minus 0, that's still 6 divided by 2, s is 3. So we can decide to say s is 3 twice. S is 3 appears twice. So we notice that the same answer, s is 3, s is 3. The answers are the same, so we don't call it real and distinct roots. The answers are equal. So basically, the nature of the answer or the nature of the root here is called equal root. So the quadratic equation x squared minus 6x plus 9 equals to 0 have equal root. Basically, answers that are the same. Let's take the third one, question 3. We are required to solve x squared plus 2x plus 9, x squared plus 2x plus 6 equals to 0. So basically all the quadratics, I'm solving them using the quadratic formula because of the nature of what we want to learn. A equals to 1, B equals to 2, C equals to 6. I'm sure you know how to identify that now. And by now you can quote the quadratic formula, negative b plus or minus square root of b squared minus 4ac all divided by 2a. Quadratic formula very applicable. X equals to negative 2 plus or minus square root of b squared, that's 2 squared, minus 4 times 1 times 6 all divided by 2 times 1. S equals to negative 2 plus or minus square root of 4 minus 24 all divided by 2. Okay, so from there we have x equals negative 2 plus or minus square root of negative 20. Okay, let's try to write that here. X equals negative 2 plus or minus square root of negative 20. Okay, so we're moving this way. Okay, all divided by 2. Now take note that we have square root of negative 20 here. Then it will be difficult for us to find the square root of a negative number for the purpose of IGCSE Mathematics 0580. Even for the purpose of IGCSE Additional Maths 0606, you cannot find square root of negative 20 for that level. So we say these have no solution, or we say imaginary solution. So what kind of root does this have? When we cannot proceed to solve it for this level, we say it has a root that we cannot imagine. It's an abnormal root, so we call it imaginary root. We call it complex root. You can call it imaginary root, you can call it complex root. So we have been able to use the quadratic formula to see different kinds of roots we can have based on how the answer appears. If the answers are completely different from each other, two different answers, two different real number answers, or real number solution, or roots, as the case may be. We'll say that's real root, or we'll call it distinct root. Or we'll say real and distinct root. They are real, they are distinct. If the two answers are same, for instance, you solve a question and you have x equals to minus 5. First answer, the other answer is also x equals to minus 5. We'll say roots are equal. Say equal values, equal roots. And when we have an answer that looks unsolvable, we say the root is complex or imaginary root. Now let's look at it graphically, a typical graph of what we're talking about. If this is x-axis and this is y-axis, a quadratic equation with a real root will typically look this way, such that we have two intersection points on the x-axis. So these are solutions to the quadratic. I can decide to write x1, x2, no problem, it's fine. Showing that the quadratic curve touches the x-axis at two distinct points, so that's real root, or what we call distinct root. For real and distinct root, it's also possible we have a situation this way. It's also possible we have a situation like this. Something like this, where you have the quadratic graph touching the x-axis at two distinct points, x1, x2. This is also real, or what we call the distinct root. Distinct root. Distinct. TNCT. Okay? Sometimes it's funny. Some of these words just get stuck in the spelling. Okay, so basically the quadratic graph can look this way or this way based on the coefficient of x squared. So if a is greater than 0, the coefficient, for instance, we have something like 2x squared. You notice that the coefficient of x squared is greater than 0. The quadratic will have this shape. But if coefficient of x squared may be minus x squared, coefficient of x squared is less than 0. If a is negative, a less than 0 to have this kind of shape. Okay, but the most important thing we are interested in this video is to show that the real root touches the x-axis at two distinct points when the graph is plotted. Okay. For equal roots, what kind of graph or situation do we have? The x-axis, y-axis. We just have the curve touching the axis at only one unique point. So basically the quadratic curve touches the x-axis at only one unique point. Sorry, this is not v, not absolute value. It's actually a curve. So I need to draw a proper curve. So if this is a quadratic curve, and let's say this is the x-axis, you just have to touch it at one unique point. Okay, right. So if this is typical x-axis, just try to figure it that way. The quadratic graph touches the x-axis at one unique point, so that if there are two values of x, x1, it will also have the same value as x2. Fundamentally, that's just x. So this is equal root. So So if you look at this, equal root basically even looks like just a tangent to the curve. You know, same situation we can have when the curve have the other orientation. When you have a quadratic curve in which the coefficient of a is negative, so the curve can look this way. Most importantly, touching the x-axis, because the root to all quadratic is the point where the curve touches the x-axis. So it only touches it at one point. That's the equal root. Okay. Let's look at the last one, the complex root, or what we call the imaginary root. In this instance, the quadratic curve does not touch the x-axis at all. So that means it's difficult to find a solution. You can picture it that way anyway. So it doesn't touch the x-axis at all. So if this is my typical x-axis, so no touching. Same way, if I have typical x-axis this way, no touching. Okay, enough of that. Okay, so you notice that the different kinds of roots, how do we differentiate them? How do we differentiate a real root from a complex root from an equal root? We use what we call discriminants. So to discriminate between all the kinds of roots we have. Discriminant in mathematics is D. So discriminant is D. And where did we obtain the D from? Recall the quadratic formula that says s equals to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Now the discriminant that helps you to distinguish or to discriminate all the three kinds of roots a quadratic can have is just found here. It's found here. That's just the expression under the square root. So that means the discriminant we are referring to, discriminant, is simply b squared minus 4ac. So discriminant D equals b squared minus 4ac. So I may not need to completely solve the quadratic equation to be able to tell us the kind of root the quadratic equation we have. I don't need to completely solve it. So we said discriminant is b squared minus 4ac. So if I'm just interested in what kind of root does a quadratic equation have, I can simply use the discriminant test to simply show the kind of root a quadratic equation we have. Now, if a quadratic equation has real roots, or what we call the distinct root, the discriminant will be greater than 0. If a quadratic equation has an equal root, the discriminant will be equal to 0. You can see as a way to remember, equal to 0. Equal root equal to 0. Quite easy to remember. Imaginary root or complex root. If the quadratic equation has an imaginary root or complex root, what will be the discriminant? Obviously, the discriminant, we want to ensure that, this is what we want to ensure. We want to ensure that for a complex root, for a complex root, see what we want to ensure. We want to ensure that the number under the square root is negative. So how can we ensure that the number under the square root is negative? The number under the square root is b squared minus 4ac, and that is discriminant. We want to ensure that it's negative. Any negative number means a number less than 0. So the discriminant must be less than 0 so that it will give imaginary root. So discriminant less than 0 for imaginary root or a complex root. Okay, settled? Now, so if we now go back to the first 3 questions, this time around, we don't want to solve the question. We just want to talk about the nature of their root. First one says x squared plus 2x minus 8 equals to 0. Let's just talk about the nature of the root it will have. A is 1, b is 2, c is negative 8. To find the nature of the root, we use b squared minus 4ac. I want to test what happens to, don't forget your discriminant is b squared minus 4ac. The discriminant d is b squared minus 4ac. So it's as if we want to just carry out the discriminant test. Okay, so let's quickly carry out that test without wasting time. B squared minus 4ac, b is 2, so that's 2 squared minus 4 times 1 times negative 8. 2 squared is 4, minus into minus 8 times 4 is 32. You do this, you have 36. You notice that this number is greater than 0. 36 is greater than 0. So if 36 is greater than 0, it implies that we obtain 36 from b squared minus 4ac. So if we have obtained 36 from b squared minus 4ac, it means b squared minus 4ac is greater than 0. And that shows that our discriminant here is bigger than 0. So if discriminant is bigger than 0, this quadratic equation will have real root. So 36 bigger than 0, real root, or what we call distinct root. Distinct root. So now I am not solving the quadratic equation. I just want to look at the type of roots the quadratic equation we have. We've previously solved the quadratic equation. Okay. The other one, that's question 2. X squared minus 6x plus 9 equals to 0. Let's identify A, B, and C. A is 1, B is negative 6 as we have done, C is 9. Let's do B squared minus 4ac. Let's carry out the test. B squared negative 6 squared minus 4 times 1 times 9. Negative 6 squared is 36 minus 9 times 4, 36. This is 0. What do we notice? B squared minus 4ac in this instance is equals to 0. Don't forget b squared minus 4ac is discriminant. So discriminant here is 0. So that means the quadratic equation have equal roots. Okay. So the question number 3 we did as part of the first set of examples. We have x squared plus 2x plus 6 equals to 0. Let's quickly do b squared minus 4ac. That's 4 minus, from b is 2, so 2 squared is 4. 4 times 1 times 6. We have actually done this before anyway. So that's 4 minus 24. That's negative 20. So, and this number is less than 0. That means b squared minus 4ac is less than 0. That's complex, or what we call imaginary roots. So those are the nature of the roots of the quadratic equation. And we have shown the graph. Now, in our IGCSE additional mathematics, this is very, very applicable. In our 0606 add maths, now we usually apply this same knowledge in the concept of intersection of line and curve. Just the same concept applicable. Intersection of line and curve, 3 cases. So case 1, if you have a curve and a straight line intersects the curve at 2 distinct points or 2 unique points. So you have 2 points intersection. Obviously, we know this is a line and this is a curve. Okay. So when we have 2 points intersection, we know that the line cuts the curve at 2 distinct points. Now, this actually basically looks like what we have just learned for quadratic to cut for quadratic curve to cut the x-axis at 2 distinct points. And we said b squared is greater than 4ac. So this is what you use to solve question when you have situation like this, case 1. Let's look at case 2. Still on intersection of line and curve. So if you have the curve like this, and we have the straight line this way, so this is 1 point intersection. Obviously, the straight line touches the curve at only 1 point. So you have 1 point intersection. Line touches the curve at exactly 1 point. So if a straight line touches a curve externally at exactly 1 point, you remember the definition of tangent. So we say the line is a tangent to the curve. The line is a tangent to the curve. Very important word. The line is a tangent to the curve. Now, how do we solve? Remember, this is just like what we have just shown. When the quadratic curve touches the x-axis at only 1 unique point, that's like equal root. So just use the formula b squared equals to 4ac. Very straightforward. So let's look at the case 3. When the line does not touch the curve at all. So if this is a curve and this is a straight line, no intersection point. Now I think you can relate to what I've just shown in the quadratic that doesn't cross the x-axis at all. Now you can relate and you are sure by now the formula to use will look like b squared less than 4ac. Now let's solve some relatable past IGCSE questions on this topic. So that will give us how it typically looks in the exam. And you know, when two lines intersect or when a line intersects a curve, you have two values of y given. Obviously, you have y equals to, for instance, x squared minus 2x plus 1, and you also have maybe y equals to x plus 5. Since you have y equals to this value and y equals to this value, first it's advisable you equate the y's, y equals to y. So we see that in problem solving as we go through the additional mathematics IGCSE past questions. So let's start with our first one. First question. We have something like this. Okay, try to make it bigger. Okay, I think this is fine. So, additional mathematics paper 12, February, March 2016. Question 1 in that exam. 4 marks question. 4 marks. Find the values of a for which the line y equals to ax plus 9 intersect the curve y equals to negative 2x squared plus 3x plus 1 at two distinct points. Okay, now because we have two values of y given, y equals to ax plus 9 and y equals to this value, first is to equate y equals to y. So I started already solution. So not necessarily I start from here anywhere, start from anywhere convenient. So I can write this value of y first, as you wish, anywhere. So negative 2x squared plus 3x plus 1 equals to ax plus 9. Now my aim will be to arrange it to look like y equals to ax squared plus bx plus c, or fundamentally to arrange it to look like ax squared plus bx plus c equals to 0. So I'll try to arrange it to look like this: ax squared plus bx plus c equals to 0. To arrange it to look like the standard quadratic. So I have negative 2x squared here, which is still fine. Any other x squared? No. Plus 3x, I'm going to transfer. I want all x together. Plus 1, I want all constant together. Negative 9 equals to 0. Try to solve it and to avoid mistakes. So negative 2x squared plus 3x minus ax plus 3x minus ax, 1 minus 9 minus 8 equal to 0. So I want to ensure that it looks like standard quadratic equation of the form ax squared plus bx plus c equals to 0. Try to achieve that. Once I can achieve that, then I can now use the conditions or the formula. So I have negative 2x squared, negative 2x squared. I want just a single x. So, and we notice we have x here, x here. So I can write plus into 3 minus a. That's a factorization procedure. All x minus 8 equals to 0. Let me quickly double check that. Plus 3 times x plus 3x plus times positive times negative, negative, that's plus times minus is minus, a times x ax. So this is fine now. This looks like what I want. I have x squared, a term in x squared, I don't need this now. I don't need this calculator now. What did I press? Calculator can leave. No, I don't want this calculator. Okay. Can I go up a little? Okay, so now we can identify a, b, and c. A is negative 2. B is all what I have behind x, 3 minus a. C is all terms without x, negative 8. Again, C is all terms without x. B is all coefficient of x, everything I have behind x. A is all what I have behind x squared. So I've identified that, and the condition of the question is very important to me. Intersect the curve at two distinct points. Intersect the curve at two distinct points, okay? That's real root b squared greater than 4ac. So I'm going to use the condition b squared greater than 4ac, and we're going to solve. So b is 3 minus a. So you have 3 minus a all squared greater than 4. A is negative 2. C is negative 8. Okay, this is fine. So I need to expand this. So I can write it twice and do the normal expansion. I can say 3 squared, that's 9. 2 times negative a times 3. 2 times negative a times 3. 2 times 3 is 6 times negative a, that's minus 6a. I'm just trying to do it in a fast way. Negative a, I'm going to square it, that's plus a squared. Okay. Greater than negative, negative, positive. 4 times 2 is 8. 8 times 8 is 64. Okay. Still on track. So from here we have a squared minus 6a. Just writing this first, followed by this, plus 9 greater than 64. Okay. So I have x squared minus 6a plus 9. This is looking like a quadratic inequality. Bring 64 to the left, negative 64 greater than 0. a squared minus 6a (55) greater than 0. Okay, so this is actually looking like a quadratic inequality, and we need to be very careful when solving this. So let's proceed with solution to this. First, I'll try to solve the equation without the inequality sign. So this is the inequality sign. I'll try to solve without the inequality sign. So I can quickly say let a squared minus 6a minus 55 equals to 0. Now you can decide to use the quadratic formula you have learned, which is negative minus b plus or minus square root of b squared minus 4ac all divided by 2a. Yes, you can use the quadratic formula you have learned. But this time around, it's just that the variable no longer x is now a. You know, the way you have x here, this time around becomes a, and you can say your a is coefficient of a squared, that's 1, b is negative 6, and c is negative 55. A is 1, b is negative 6, c is negative 55. But obviously, I'm not going to use the quadratic formula here. You can pause the video, make use of it, and you join me. So definitely this will now give answers to a, not x. So a will have two answers, unlike when we're using x in our quadratic formula. So, but I will be using factorization quickly to figure out the answer here. So if you don't have an idea of factorization, you need to watch a video where you know how to factorize. So the purpose of this is not to teach factorization. So quickly, we have the product is negative 55. That's 11 times 5. 11 times 5 gives negative 55. Then I need negative 6 at the middle. So I can have 5. Let me put minus here. So 5 minus 11, that's minus 6. 5 times minus 11 minus 55. So I know if I solve that with my factorization, which I'm not going to teach here, a will be equals to 11 and a will be equals to minus 5. A is negative 5, a is 11. Now remember that we actually want to solve the inequality which says a squared minus 6a minus 55 greater than 0. So I also have a video on inequality, quadratic inequality precisely. You can quickly watch how to solve this. But I can quickly just take this briefly. And we have two answers and we need to know how it works since this is an inequality. So what I'm going to do is I can just draw a small number line, just a small one. Don't need to write all your values. This is 0 basically. This is negative 5 towards the left. This is 11. So this 0, in order not to get confused, I can just clean it. Definitely I know 0 exists between negative 5 and 11. So to figure out the answer of quadratic inequalities, you need this. Now the answers can be in this region, or this region, or this region. So these are possible regions where the answer can be here, here, here. And I'll quickly share a secret with you. For quadratic inequalities, the answer can either be here, where you have to merge minus 5 and 11 as a single answer, merge the inequality. Or if you carry out your test, the answer can either be here or here also. So in most instances, if an answer is here, satisfy this region, it also satisfy this region. If it satisfy this and this region, it will not satisfy the middle region. So possible answers are either A and B or just C. Possible answers are either in the region A and B or simply C. So you can watch my video on quadratic inequalities, but I think with this you can understand what we're trying to say. So I'll quickly carry out a test. Let's test any number that falls within minus 5 and 11 to see if this region is satisfied. To see if that region is satisfied for that inequality. So let's pick 2 falls in that region. Let's pick 2. So for the inequality given, I want to put 2 here, and I want to see if it is greater than 0. So a is 2. So a squared turns to 4, that's 2 squared, minus 6 times 2, that's 12, minus 55. Let's see if that number is greater than 0. 4 minus 12, that's minus 8. Minus 8 minus 55. Obviously, this is a negative number. Minus 8 minus 55 is a negative number, and that number cannot be greater than 0. A negative number cannot be greater than 0. So it means the middle region is not satisfied. So this is out. So the implication of that is the middle region is out. So if the middle region is out, we can quickly check this region and this region. So let's check a number greater than 11. Let's try 12. Any number in this region, 12. Let's put 12 there. So a is 12. So you have 12 squared, that's 144, minus 6 times 12, minus 55. Let's see if that number is greater than 0. So we have 144 minus 6 times 12, minus 55. So that's 17, obviously greater than 0. So implication of that means possible answer can be in this region. Okay, let's test in this region all numbers less than negative 5. Let's just put minus 8, negative 8. Let's test with negative 8. So put it here, you have minus 8 squared, that's 64. Minus 6 into minus 8, minus 55. Let's see if that number will be greater than 0. That's 64 plus 8 times 6 is 48, minus 55. 64 plus 48, 112 minus 55. So 112 minus 55 is a positive number which is greater than 0. It means this region is also satisfied. So in real sense, the solution to the inequality can say how the question leads to inequality. So that means all topics are quite important. Numbers less than minus 5, numbers less than negative 5, numbers less than negative 5, and numbers greater than 11. So the region satisfying the inequality, quite easy, numbers bigger than 11, and numbers less than negative 5. And cannot be merged. Please don't merge it. Once they go their separate ways. So because you have variable a in the question, so we say a less than negative 5. You can just separate with a comma, and we say a greater than 11. And that's the answer satisfying the question. So we're done with the first question from our past question. Let's move on to question 2. Question 2. So here I have question 2, which says O6 paper 12, May, June 2015. Oh, that was question 1 in that exam. But now serving as question 2 in our own solution series. Given the graph of y equals to 2k plus 5x squared plus kx plus 1 does not meet the x-axis, find the possible values of k. So this has been made very simplified because you only have one possible value of y here. So it's as if this is arranged to look like, this is well sorted to look like y equals to ax squared plus bx plus c. So once you can, this has been sorted to look like that. So we have y equals to 2k plus 5 x squared plus kx plus 1. We only need to identify a, b, and c. A is what you have behind x squared, 2k plus 5. B is coefficient of x, that's k. C is constant, the term that does not contain x at all, that's 1. Okay, don't know why I'm shading this one. 1 is 1, stop shading. Okay, so we need to look for the keyword. The keyword is does not meet the x-axis. Okay, so does not meet the x-axis. That obviously look like a complex root or an imaginary root. So we're going to use b squared less than 4ac to figure that out. So b is k, so we have k squared less than 4 into a, 2k plus 5 times c times 1. Okay, so eventually I'm going to throw away that one. So we have k squared less than 4 times 1 is 4. So 4 multiplies 2k plus 5. That's 8k plus 20. So transfer all this to the left because this is looking like quadratic because of the k squared there. It's just quadratic. K squared minus 8k, okay, minus 20 less than. This has been transferred, this has been transferred. Obviously nothing left here. So that's less than 0. Less than 0. Okay. So still giving rise to another quadratic inequality. So you can take your time to solve kind of quadratic that look like x squared minus 8x minus 20 equals to 0. That's if you only know how to use the quadratic formula. I just change k to x. X squared minus 8x minus 20 equals to 0. You can solve that and obtain two values of x. But here, obviously, I'm not going to use the quadratic formula. I'll just do a kind of quick factorization. But I will now obtain two values of k. So that means the values of x you have obtained with your quadratic formula will be values of k I'm going to be using for this solution. So first I need to ignore the inequality by saying let k squared minus 8k minus 20 equals to 0. So I can quickly carry out factorization, multiply coefficient of, I'm not going to teach factorization here. So 10 times 2 is 20. Okay, I need that. 1 times, I need negative 20. So 2 minus 10, 2 minus 10, negative 20. 2 times minus 10, negative 20, 2 minus 10 minus 8. Okay, so on solving that, I can quickly say k equals to 10, k equals to minus 2. You need to be very careful using my shortcuts if you don't really know what I'm doing here. Okay, you can make a video on that separately. But here, k is 10, k is negative 2. Okay, so in order to solve the inequality now, so that's the aim, the aim to solve the inequality. I'll go back to the inequality. K squared negative k minus 20 less than 0. So I said we need to draw a small number line quickly just to depict what I have. So that will help to determine the region satisfying the inequality. So obviously negative 2 will be to this side of number line, 10 will be here. So I said we have 3 places we can test. We can test at A, test at B, test at C. So I like to carry out my test from the middle, okay? And I can give you a secret. Once it has satisfied the middle, pick your answer and move on. Another secret, once you satisfy this to the left, obviously the answer will be here and here. Once you satisfy this to the right, obviously it will satisfy this to the left. Anyway, but you can always carry out all the tests, but those are general observations that is definitely correct. So let's test from the middle and let's see whether this inequality is satisfied. Let's see whether this inequality is satisfied. A number that lies between negative 2 and 10, or between negative 2 and 10, any number, if you like, use 9, use 8, use 7. You can even use minus 1, but I'll just use 0 to save my stress. So quickly use 0 for that. I'm going to have, anywhere I see k, I'll put 0. 0 squared minus 8 into 0. So anywhere I see k, I'm going to put 0. Negative 20. Let's see. This is 0. Negative 8 times 0 is 0. We're left with negative 20. Is negative 20 less than 0, as you can see from here? Because it is expected that anything that satisfies this inequality should be less than 0. So negative 20 is less than 0. So this is correct. So that means inequality is satisfied in this middle. So I'll pick my final answer straight up. So final answer will just be the region satisfied, which is here. So in between negative 2 and 10. So I'm going to merge. So final answer will be negative 2 less than k less than 10. That's the way to write the answer. One more explanation. K less than 10, yes, obvious, look at it, all values below 10, and all values from -2 upward, but it won't get to 10. All values from -2 upward, that means K is bigger than -2. And if K is bigger than -2, if you want to change the narrative, if you swap, that means -2 is less than K. So for instance, if I say 5 greater than 2, if you swap, that's 2 less than 5. You can check out the video on inequalities and I'm sure you have a perfect understanding of that. So the way we write the answer is to start from the smaller one, -2 less than K less than 10. And if you are curious and you want to interpret that, you can say that as K is less than 10, satisfied. -2 less than K, which means K is bigger than -2. Okay. If you swap inequality, you must also swap. If you swap position, you must also swap inequality sign. For example, if I say A less than B, if I start with B, I will change narrative to B greater than A. If I say X greater than Y, if I start with Y, it will now be Y less than X. Those are just some basic rules of inequalities. Okay, so that's that. Let's move to the third question from our past question. Oh, question 3. Let's move. Okay. Okay, no real roots again. Just look like what we've just completed doing. No real roots. So the keyword is no real roots. So let's identify that. Do we have two values of y here? No, this has just been well arranged to look like ax squared plus bx plus c equals to 0. So let's just identify a coefficient of x squared. A is 1. B is what do you have beside x? That's 2k. It's been well arranged. Then c is terms without x. Terms without x because the quadratic equation is defined. It has x squared. So the quadratic equation is an equation in x. So your constant will be term without x. And that's 4k minus 3. Okay. No real root, b squared less than 4ac. Let's see if we'll be able to show. B is 2k, so we have 2k all squared less than 4 into 1 into c, 4k minus 3. Oh, this is nice. 2 squared, that's 4. K squared, okay? 2 squared, k squared less than, open the bracket, 4 times 4, that's 16k, negative 12. I think all is divisible by 4. So let's divide through by 4. Let's see what we have. So 4k squared divided by 4, that's obviously k squared. Less than 60k divided by 4, that's 4k, okay. Negative 12 divided by 4, or that's 3. So transfer all to the left, k squared minus 4k plus 3. When you transfer them to the left, the sign changes from normal mathematics rules. Okay, less than, all these have been transferred, so nothing more there, less than 0. K squared minus 4k plus 3 less than 0. So I'm able to prove that. So prove that, we'll be able to do that. Proved. Show that k satisfies. Okay, done. Solve the inequality. So obviously testing inequality here. K squared minus 4k plus 3 less than 0. Okay, to solve, I like to first ignore the inequality sign by saying let k squared minus 4k plus 3 equals to 0. Obviously, I'm not going to use quadratic formula again, as I've said. So I think I can use minus 1 minus 3. Minus 1 times minus 3 gives plus 3. Minus 1 minus 3, that's minus 4. So quickly, k is 1, k is 3. You notice that I just swap the signs here, okay, to get my answers, okay. That's for those that understand factorization. And also, you need to be very careful. If k is having a coefficient here, let's say k is having 3k squared here. If you do this, you're going to be wrong. So if you don't understand the shortcut, just leave it. When I make a video on it, then I can refer you to it. So k is 1, k is 3. So quickly I can have a number line. So the best is to solve the quadratic anyhow you understand them. But anyhow you solve, we will all arrive at the same result for the quadratic. So in order to now solve the quadratic inequality now, we need to present the number line. Let's present our number line. The smaller answer is 1. So yeah, obviously. The bigger answer is 3. So let's test the region that will be satisfied. Let me try to test here. Although I know it won't be satisfied anyway. But let's test. So numbers bigger than 3, let's choose 5. So 5 squared, that's 25. Putting it here, I want to see if it will be less than 0. Minus 4 into 5 plus 3, that's 25 minus 12 plus 3. 25 minus 12, I think that's 13. 13 plus 3 is 16. Is 16 less than 0? No. You can see it says it must be less than 0 from what I'm showing you here. So 16 is not less than 0. 16 is obviously greater than 0. So region from 3 upward is not satisfied. In real sense, I know and I am very sure that from 1 below will not be satisfied. So let's test between 1 and 3. Number between 1 and 3, let's put 2. Let's see. Let's put 2 here for k. So 2 squared, that's 4. Minus 4 into 2 plus 3. That's 4 minus 8 plus 3. 4 minus 8, that's minus 4 plus 3. 3 minus 4, that's negative 1. Negative 1 less than 0, correct. So this region is satisfied. So once this region is satisfied, my solution set looks like 1 less than, okay, the variable there is k. So 1 less than k less than 3. That will be the solution to the inequality. 1 less than k less than 3. Let's move on. This was question 3, okay. So we can move to question 4. Question 4. To make that bigger. Okay, so we have the curve intersect the straight line as 2 distinct points. So let me identify my keyword. 2 distinct points. So that's obviously b squared greater than 4ac I will use to solve. Okay. Okay, so you have 2 distinct points. Then obviously we have 2 values of y given. That's another thing we need to check. So this is a curve, this is a straight line. So once you have 2 values of y given, the first thing is to say y equals to y. So y here is 2x squared. Any of the y can start, no problem. Plus k plus 4 equals to, intersection means just equate them first. K plus 4 all into x. So 2x squared plus k plus 4 equals, open up the bracket, you have kx plus 4x. Okay. This is looking nice. So let's transfer all the expressions on the right to the left. Just want to package it. 2x squared, okay, no problem, minus kx minus 4x plus k plus 4. On transferring this and this, nothing left on the right, equals to 0. Okay, so we want to make it look like ax squared plus bx plus c equal to 0. How do we achieve that? So we need to group this x as a single entity. So that's just factorization. 2x squared. So here I have k, I have 4. If I like, I can just write k plus 4, then I put x here. So I like to quickly check it back. Negative k times s, negative kx. Negative times 4, that's minus 4 times x, minus 4x. So that's correct. Plus k plus 4, that k plus 4, I can just simply group it if I like. Plus k plus 4. Yes, it's good we group it, because those are the terms without x. Everything equals to 0. Because we have 2x squared negative into k plus 4x plus k plus 4 equals to 0. Let's identify a, b, and c. A is 2, coefficient of a is 2, what you have behind x squared. B is all what you have behind x, that's negative into k plus 4, that's b. Then c is all terms without x, because it's a quadratic in x, so that's why we see, that's why we see something x squared. It's a quadratic in x, something x, the other is constant, terms without x, k plus 4. At two distinct points, that's the intersection point, right? At two distinct points, okay, so we can say at two distinct points, b squared greater than 4ac. Okay, so b is negative into k plus 4. So we need to be very careful here. So this is the whole of b all squared greater than 4. Okay, a is 2. Oh, let's check. C is k plus 4. So once we can do this, I guess we're done. So the first, I'll just, this negative, I'm going to square it. Negative square obviously gives positive. So k plus 4 squared. So we can quickly do the expansion of k plus 4 squared. That's k plus 4 multiplies another k plus 4. So that's k squared. So I can just erase the positive behind that. K squared plus, what I just need to do is to square the first, k squared, multiply this, that's 2 times 4 times k. And you have to be careful of the signs. Here you have plus signs throughout. 4 times 2, 8 times k, 8k. Positive signs throughout, no problem. 4 squared, 4 times 4, that's 16. Greater than 4 times 2, 8 into k plus 4. Becoming more interesting, k squared plus 8 squared plus 16. Greater than 8k. Okay, on expansion, 8k plus 32, okay? I think I'm right. Coming down, I don't need you here. Remain where you are. Okay, so we have k squared. Wow, I see. I see. K squared plus 8k minus 8k plus 16 minus 32 greater than 0. Plus 8k minus 8k takes care of itself. K squared 16 minus 32, that's minus 16, greater than 0. Okay, no problem. K squared minus 16 greater than 0. Anyhow, if you like, you can say this is k minus 4, k plus 4 greater than 0 from the concept of difference of two squares. If you like, you just leave it, no problem. So how do we solve this quadratic inequality? Quickly, let's k squared minus 16. I will just change this. I will just change what do we call it? I'll just change this to equal to 0. That's what we've been solving. Okay, so you have k squared equals to 16. And so since you have k squared and quadratic must give two answers, so we take square root of both sides. K squared square root 16 square root. So we must generate two answers. So k will be square root of 16 is 4 and also minus 4. So k is 4, k is minus 4. You must generate two answers since it's a quadratic, since you have k squared. So square root of 16 is plus or minus 4. So to get the proper answer to the To get the proper answer to the quadratic inequality, as we have rightly said, what we need to do is just to come back here and see the regions that are satisfied. We have said k is 4, k is minus 4. Let's draw a number line. The smaller number can be here, -4. The bigger number can be here, 4. So I prefer to always start the test from the middle. So let's test middle. Between -4 and 4, any number lies between -4 and 4. Let's just use 0. If you put 0 there for k, so that's 0 square minus 16. 0 square is 0. So you have 0 minus 16 is that's minus 16. And it says k square minus 16 should be greater than 0. Okay, that's what the inequality says. K square minus 16 should be bigger than 0. So minus, and final answer we've got is minus 16. Is minus 16 greater than 0? No, that's false. Minus 16 is less than 0. So the middle region, in real sense here, is not satisfied. Not satisfied. So if you test to the right and to the extreme left, it will be satisfied. So answer basically will be all numbers from -4 down. So k less than -4, comma, and all numbers from 4 up will also be satisfied. You can just test it. K greater than 4. So k less than -4, k greater than 4 is the solution set of that. Let's move on. I guess this should be question 4. Don't want to leave any question unsolved. Okay, this is our question 4. So let's move to our own question 5. So this is our own question 5. Oh, this is nice. I'm saying something we have not really solved. Tangent. The keyword tangent. Identify the keyword there, tangent. Identify that we are given two y's, y here, y here. That means there's an intersection between a curve and a straight line. Y equals to mx minus 5 is obviously a straight line. And this is curve. Okay, so first y equals to y. So anyone could start with any of the y. So I'll just prefer to start with x squared plus 3x plus 4 equals to the other y is mx minus 5. So x squared plus 3x, I could quickly transfer minus mx because I like all x to be together. All expression here has been transferred, so nothing there, nothing left there, so that's 0. All expression to. So we have x squared plus, just write 3 and m, bring out the x, plus open bracket 3 minus m, x plus 4 plus 5, 9 equals to 0. Always endeavor to check here by expansion and be sure you are right. 3x minus mx. Okay, so a is 1. It has looked like as squared plus bs plus c, standard quadratic. B is what we have beside x, 3 minus m, and c is the guy that doesn't have x at all, 9. I'm sure we want to find m. Let's see. Oh, values of m. Take note. It says values of m. So obviously m will have more than one answer. So and it says it's a tangent. So that means you touch the curve at exactly 1 point. That means b squared equals to 4ac. It's a tangent. Touch the curve exactly 1 point. B squared equals to 4ac. B is 3 minus m. So I have 3 minus m. 3 minus m all squared equals 4 times 1. Oh, c times 9. Oh, we're lucky here. This is not. It's quadratic, but it's not an inequality. There's no less than, there's no greater than. It's just equal to straight. So it's not an inequality. So let me erase these points. So 3 minus m all squared, that's 3 minus m times another 3 minus m. I'm going to quickly square this. 3 squared, that's 9. 2 times negative m times 3. 2 times negative m times 3, that's negative 6m. Just a fast way of doing that for me. Negative m squared. Negative squared is positive, m squared is still m squared. Equals to 9 times 4, 36. 9 times 4 times 1, 36. Oh, so this is m squared minus 6m plus 9 minus 36 equals to 0. Once we see squared, that's quadratic, 10 to 0. So you have m squared minus 6m. This looks like minus 27 equals to 0. It looks like that. Yes, so this now be solved to obtain answers. But quickly, I'm not going to use quadratic formula. I need minus 27. That's 9 and 3. I need minus 6. I put minus 8. 3 minus 9 minus 6. 8 and minus 9 minus 27. So m is 9. M is 9. M is negative 3. Two answers. 9 and negative 3. Yes, m is 9. M is negative 3. Okay, that's perfect. Let's move to question 6. Okay, of our question, question 6. Does not meet. Wow, 5 marks. 5 marks. Does not meet. Okay, first, we can identify the keyword here. Does not meet. And we're also given 2 values of y. So first, we can quickly say y equals to y. Let me use this y first. 9x squared minus into 3k plus 1x plus 5 equals to the other y, 1 minus 2kx. A very smart examiner, because you will notice that you observe that there is x here and there is x here. So I need to bring all x together. So this is what I'm going to do. I have no choice than to open up the left side. 9x squared minus 3kx minus x. So I have to open it up because there's still another x here that needs to come and join it, Negative 3kx negative x plus 5 equals to 1 minus 2kx. Such a smart way to see if you actually understand the concepts. So I'm going to have 9x squared negative 3kx plus 2kx minus x plus 5 minus 1 equal to nothing more, equals to 0. I think I'm right. 9x squared 2kx minus 3kx minus 1kx, so I can just say negative kx minus x, okay, plus 4, yeah, equals to 0. Now I can package it. 9x squared, I need x to be outside. I can say minus into k plus 1 x plus 4 equals to 0. Let's double check. Minus kx minus 1x plus 4 equals to 0. Okay, I think that is fine. So the condition is does not meet. Okay. So does not meet means b squared less than 4. So that's what we're going to use because it doesn't meet. So a is 9. I'm going to erase this. A is 9. B is negative. No, negative is outside. Into k plus 1. C is 4. Taking that, b squared, that's negative into k plus 1. No, show that here. Negative into k plus 1 squared, that's b squared, less than 4, a 9, c 4. Okay, negative squared, the first is the negative square gives a positive, so it won't have effect. So we left with k plus 1 whole square, so that's k squared, okay, 2 times 1 times k plus 2k 1 square plus 1, okay, less than, that's 144. So k squared plus 2k, okay, I think I'm right. K squared plus 2k minus 143 less than 0. So we have that, which I know we can figure out by now. So if we solve, we'll get 11 and negative 13. If we solve, we have 11, k is 11, k is negative 13. Anyway, these are not the answers, so we need to check the region satisfied by inequality. So you can just use quadratic formula to solve that. So I'm so much interested in the inequality answer. So I'm going to bring negative 13 first. I'm going to bring 11. You notice that coefficient of k squared is positive. Coefficient of k squared here is positive. This is less than 0, so the answer will be here. It's just general observation. Since we have explained the concept, so we can just figure out the answer as negative 13 less than k less than 11. Ensure the small number is here, big number is here. Okay, negative 13 less than k less than 11. The concept have been explained, and you can also check the inequality video. Okay, so most likely we'll take one more, and that will be the end of this topic. Or question 7, tangent. Okay, all questions are from the past question. Okay, they said we want to find the values of k for which the line is a tangent to the curve. Keywords: tangent, I see. Two values of y. So two values of y, I need to equate them first to say y equals to y. Okay, so I can quickly say y here is actually 2 minus kx. Yes, I can do that. So I can say y equals to y. So 2x squared minus 9x plus 4 equals to the other value of y is 2 minus kx, as we have rightly said. So you have 2x squared minus 9x plus kx plus 4 minus 2 equals to 0. So we have 2x squared minus 9x plus kx, 4 minus 2 plus 2 equals to 0. So if it's a tangent to the curve, we use b squared equals to 4ac. As we have rightly said, we can say that b is k minus 9, Okay, let me quickly show that. From here, we know that this is 2x squared plus, I can say plus, into k minus 9 of x. If you expand that will give you kx minus 9x plus 2 equals to 0. Now you can easily identify your a, b, and c case. So you can easily identify your a, b, and c. So b is k minus 9. So I have k minus 9 all squared equals to 4. A is 2. Then c is also 2. Okay, this is nice. So k minus 9 all squared. Okay, since it's equal to, there could even be a simpler way of doing it. Okay, no problem. Let's just expand. That's k squared minus 9 times 2, 18k negative square plus 81 equals to 4 times 16. Okay, so that's k squared minus 18k plus 65. 81 minus 16, that's 65. So basically, this is not a factorization lesson, so I won't go through the process of doing that. So k squared minus 18k plus 65 equals to 0. If you like, you can just use quadratic formula. You know, you can be very fast with that. Okay, so I'll just quickly provide the answer. Mode equation 5. I can just use my calculator straight to figure out 1. 13 and 5. So k is 13, k is 5. K is 13, k is 5. So it has equal to, so we don't have issue with testing anything. We're not testing anything. For for the curve to be tangent, for the line to be tangent to the curve, it is equal to, and that's the only one that doesn't have an inequality there. So just b square equals to 4ac. So this is quite easy to solve and get an answer. So at this point, I believe you have been able to understand the concept of um, line tangent to a curve in your IGCSE, additional maths, and I took the concept, explained how everything works, and I've been able to look at few past questions. So with this, you are fine with this topic. In subsequent video, we'll pick other topics and we'll pick questions from past questions and we'll explain them. Thank you. Bye bye.